With inverses in the past, when we did inverses, we did the flip-flop x and y and resolve. So you've done this basic idea before. You've done y equals 2x minus 3. And to find the inverse of that, you would have said x equals 2y minus 3, and then you would resolve. What happens here, you get x minus 3 all over 2 is y. Now, graphically, what this would look like then is that you would have 2x minus 3. The other one was alpha equals x minus 3 over 2. If you look at that graphically, what's that? Oh, yes, thank you. I just realized I did that when I looked at the graph. I'm like, wait, there's no balance there. Remember when you do these things graphically, what happens then is there's this imaginary line that goes through everything that makes them symmetrical, y equals x. So that for every point that's on the graph, on each graph, they're equidistant to the imaginary line of y equals x. That's why inverses work, okay? So we're basically going to do the exact same thing with logarithms to exponential form. Logarithms in exponential form are inverses of each other. So, excuse me, if we look at a real basic log, y equals log base 2 8 equals 3. We okay with that? Exponentially, that means what?
2 to the third power equals 8?
Yes. So 2 to the third power equals 8. So if I put in, actually I should do this. If I put these two values in a graph, let me show you how to graph a logarithm real quick. Or just use it, how you come up with the buttons with the bases and stuff like that. When you look at graphing logs, if you're using your calculator, when you deal with inverses, you're still going to wind up with that imaginary y equals x as being symmetrical to all points. So if you hit alpha window, option number 5 is log base. And it's going to ask you, what base do you want? Well, in this one I did base 2. So I put log base 2, and it was 8, right? Actually, you know what? I think I have to put an x in here. Yeah, sorry about that. I got to put in x. Sorry. Do log base 2 of x. Forgot that I need to have a variable. And then my next graph would be 2 to the x. And then my next graph would be just x. If you look at all three of these, there's my log, there's my exponential, and there's my y equals x. They're inverses of one another. Okay? They're inverses of one another. Logarithms have a vertical asymptote at y equals x. I'm sorry, at x equals 0. Exponential functions have horizontal asymptotes at y equals 0. That's how they become inverses of one another. So this one's diving up, and this one's diving down, and so on. So when we go to talk about inverses, remember what you can do to show that they are equal to one another is that you could, we did this before, when you substitute in one for the other and you simplify it out, you're going to get x. Yes? No? Vaguely remember? No. So what happens here, if we go back to the idea where we had y equals 2x, let's just leave it as y equals 2x, and then the inverse of that would have been 1/2 x equals y. Everybody okay with that? If you substitute in for one another, if I take this value of x into here, I get 2 times 1/2 x, I get x. If I take this value and I put it here, you get 1/2 2x, I get x. Since they both equal x, that means they are inverses of one another. That's how you show that things are inverses. So when you deal with this in terms of logarithms, if you have your two generic forms here, if I put in one for another, if I take log of base b of b to the x, when these bases are the same, that exponent, x, drops. That's how they undo one another. If I do the same idea on the other side, if I do b to the log base b of x, again, this is a base, and this is the same base. The log has been, it's kind of a made-up term that I use, exponentiated. It's been turned into an exponent. I don't think it's a real word, but it sounds right. So by moving that logarithm up as an exponent, you have the same bases, that base b. That basically undoes itself, and then that value of x drops. So like on number 46 on that homework last night that you looked at, you had no idea. I think it was 5 to the log base 5 of x. Are those the same bases? That's your answer. What's that? That's your answer then. It undoes itself. Okay? This is how we're going to be able to solve variables. This is how we're going to be able to solve for variables when they're exponents, by using log bases, or solving for variables that are logs by using exponentiation. Okay? It's a little weird of a lingo here, but it's, as you start to go through it, do a couple examples of why we set these things up, it is unbelievably quick to work with. It's unbelievably quick to work with. Let me show you an example. One of these. So now if I want to simplify these, anytime that you have a logarithm that doesn't have a base, it means that it has base 10. Base 10 is what we call common logarithm. So if you just see you ever see it just says log of 2? The base is implied that it's a 10. There's a button on your calculator that says log. That's common log. That is in base 10. So if it doesn't say it, it means it's base 10. Are those two the same bases? What's your answer? 2.
What do you mean, are they the same bases?
Is this 10 and this 10, are those the same?
Oh.
Since, hi!
Uh-oh.
So if you have a base and an exponent,
So what?
and if that exponent has the same base,
B?
good luck.
I beat you.
Well, don't have
I
good luck.
beat you.
Then it's a double-edged sword.
I hope those glasses even help when they're so dirty. It's probably like
They're
just as
dirty.
close.
Want to see?
Probably like just as close.
Whatever. Same deal here. Log base 3 of 9x. I can't do anything about that quite yet, but can I convert that 9 to become a base 3? This is where a lot of your conversion stuff comes into play. Knowing about your exponents, knowing about the rules of exponents. How can you rewrite a 9 to have a base 3? Well, 9 is 3 to what power? Squared. So what you would do here is you try to think of ways that I can rewrite this value in terms of that base. So it's log base 3 of 3 squared times x. Which means, are those bases the same? So what drops? 2x. And there's your answer. It's a lot of being able to convert exponents and bases together. Okay? I have some duct tape. Do you have some duct tape? They're broken.
No, they're just really like dirty.
Why are you using your fingers?
Yeah, I don't know.
Because there's like,
It's not a good idea.
there's like other
What?
stuff on there that I'm trying to like scrape off.
I said if they're that dirty, I doubt they even know.
They're so dirty.
And then
Okay?
just started using
Which
their
means
hair.
that we can simplify logarithms then that don't have same bases. So if I see log base 2 of 64, That means I need to figure out 2 to what power is 64? 5 is 32. 6. This is the same thing as saying log base 2 of 2 to the 6th. So therefore, if I simplify that out, what do you get? 6. And you're using inverse properties to get there. You're getting the same bases so that way things can drop. Okay? Log base 25 of 5. Well, I need to excuse me. Was that a sympathy cough there? Thanks, Jared. If I want to sit there and think about log base 25 of 5, that means I have to rewrite a 5 into that base of 25. Well, 5 is 25 to what power? What is it, negative? If it's negative, then it turns into a fraction, doesn't it? Yeah, I see where you're going. Now, isn't 5 the same as 25 to the 1/2? So you might have to think of it in terms of that, working backwards from stuff, thinking about using an exponent as a root. So this would be the log base 25 of 25 to the 1/2. And again, this base and this base, because it has an exponent, these two are the same, which means they undo one another. So your answer is 1/2. Yeah, Trey.
Look at that. Because how can you put 5 to the 1/2 and 25?
I'm not saying 5 to the 1/2. What I'm saying is,
Oh, okay.
I'm saying 5 is 25 to the 1/2 because 1/2 means square root. That's what I'm getting at. Does that make sense? Okay. Log base 6 of 1. I don't know, is it? 6 to the what? Because if you go back to what you did yesterday, you're on the right track. Because one of the properties we talked about yesterday was it log base b of b? What was it equals? Wait, no, it was log base b of 1 is 0, and log base b of b was 1, I believe. I have to go back and double check. It's been a year since we've done logs. So you're saying was? So this has to be what? This has to be, not 6, sorry. 0. It has to be 0. Because 6 to the 0 power is 1. Okay? That's why that works. In order to make this to get to a 1, think of it this way. It's log base 6 of 6 to the 0 because 1 is 6 to the 0. Good pickup. Memory. All right. That's a 0, not O. Sorry, sometimes my handwriting's bad. You're shaking your head again.
I'm not.
You thought about it. And last one. 10 to the log of 4. Too confusing. 10 to the log of 4. What is it? What's the base of the logarithm? So what's the answer? 4. The base of the logarithm here is 10. Since you don't see a base, remember, it's log base 10. So this one, I'm going to make it, oh, I almost made it. This is the same thing as 10 to the log base 10 of 4. Now, what we're doing here is we're writing it backwards from this style. Sometimes you can have a base here and a base up here. If the bases are the same, values drop. Okay? That's how it's going to work.
I don't get that. How can you just put like a 10 there?
For this reason. What's the coefficient?
Right.
What's the coefficient?
2.
All right, let's try this again. What's the number in front of x?
1.
Okay. Do you have to write it?
No.
Same deal. If I just say log of 3, it's implied that this is base 10. It's math etiquette. They just don't put a 10. That's it. No reason. Yeah, save an ink every once in a while. That just means it's log base 10. It's a standard, it's called common log. Your common log is log base 10. The button you have on your calculator is in base 10 until you hit that alpha window 5 or whatever it was. Okay? Base 10 was the common log forever until, I don't know, graphic calculators came around in the past, I'd say about 5-6 years, when you had the options to change bases by pressing a button on the calculator. Because back in my day, if I had to do a log base 3 divided by the log base 7, I can't do that. I had to do some conversions. Nowadays, you can just press buttons on your calculator. So, this is common log, so if you see it written as, they're one and the same. Okay? Excuse me. Speaking of common log, there's also this thing, sometimes you might have what's called log base E. If you have log base E, you're going to find out real quick, you need to have E because you're going to have what's called natural log. Natural log, they use the letters ln. Log of the natural is what they used to call it. But then they just said, hey, that sounds silly.
Log of trees.
Because if they had log of the natural, then they're thinking about Wonder Bat. No, the natural.
I think of log of trees.
Robert Redford. He had a busted spleen. He had a home run, busted the lights. Roy Hobbs. Nothing? Wonder Bat? Help? Homer Simpson? The Ringers softball episode? He had made Wonder Bat? And it was like, Daryl.
Who's Homer Simpson?
Get out of here. How do you guys never seen The Natural? It's a great movie. I think it won like an Oscar or
All
2.
the movies you say are great, you're the only person that's seen them.
Yes.
Them's fight words.
No. And then sometimes Emma will be like, oh yeah, I've seen that movie. But
And I think she says it just to make me feel better.
Yeah.
And she's like, yeah. No, seriously, The Natural is a Robert Redford movie. It's about an old baseball player. It's a really cool movie. I do recommend that one. Homer Simpson, the Simpsons episode Simpson at the Bat. It's a whole bunch of old baseball players. They had cameos in it. My favorite episode of all time. It's fantastic.
Only Simpsons I ever watched
should.
was the movie.
That's good too. Spider. Anyway, so these two mean the exact same thing. Anytime you see the lettering natural log ln of x, it can be rewritten as log base e. Okay? log base e. We don't write log base e because that takes too long. They've simplified it to write ln because that stands for natural log. Log of the natural. I know. I wasn't there when they made these rules. I was just, I'm just a facilitator. I'm a facilitator of knowledge. I wasn't there at the. I wasn't invited to dinner to talk about this. Okay. I wasn't there. Can't blame you. So the reason why we have to use this natural log stuff is when we start working about inverses here, and I think I had one.
Why is there a foot on the board?
What's that?
Why is there like a foot on the whiteboard?
I have no idea.
Do you draw it?
That's gross. That's big. Ask me.
Hi.
That wasn't as exciting as the first time. Do I feel less exciting every time?
I'll get it to you guys. We've had so many kids that have been sick in between these two classes, so we're just getting caught up. Morning, Judah. Excuse me. So if I want to find an inverse here, and I want to find inverses of a natural log, and this is why we have natural logs in log-based e's, so they can undo one another. If I want to find the inverse of this, we do the exact same thing. We start by flip-flopping x's and y's. But now what I want you to think of is natural log is log base e. So when you go to rewrite these things, you know that you're going to have x equals log base e of y minus 1. Oops. Y minus 1. And now in the back of my mind, I sit there and think, well, if I needed to undo this base, I'd have to, like I called it earlier, exponentiate it. What would I have to make a base in front of the log to undo it? E. I'd have to e both sides. And here's what that means. I'd have to make this into a base. So now I get e to the x on one side. These two e's undo one another. It's the same idea as 5 to the log base 5. They're the exact same bases, which means the other stuff drops. Someone step on a duck. And how do I move 1? Add it. These two then are inverses of one another. They're inverses of one another. Remember, the idea that you're working with inverses is that you have these two other properties. B to the log base B of x is x. And then, what's the other one? Log to the, and then log base B times B to the x is x. If these two are the same, or if those two are the same, that's how they undo one another. Okay, that's how they undo one another. Okay. Next. What have we done? All right, and then I'm trying to think if because we have. I want to try and be done with. I don't know. Do a 4-day weekend. Because we have. Yeah, I don't think we'll finish it out anyway. Okay. Because the next little bit really is graphing, and I don't know. This doesn't take long, but I think I'd rather do another couple examples of inverses with you guys, just to make sure we get it. So let's do the same thing. Let's find the inverse. we'll do the inverses again. Okay. Excuse me. How many times did you guys sing that song yesterday? Big and heavy as wood.
Not even more.
You guys could at least humor me.
Put it back.
Anyway, so when you find an inverse, what's the first thing you're going to do? Switch the x and y. Good. So that means I have x equals log base 7 of 49 to the y. Now, I need to see if I can rewrite 49 as a base 7. 49 is 7 to what power? 2. So if you wanted to rewrite this right away, you know, just say, oh, I know it's going to be 7 squared, so I just go x equals log base 7 of 7 to the 2 y. Do those... Sorry, excuse me. I need to drink water about this. Apparently. And what was killing me is that I was feeling so much better yesterday, and then I rest today, and it's bad.
You didn't rest today?
No, I regressed. I felt so much better yesterday afternoon, and then last night it got bad again. Okay. What can I do on the right side of this equation? The 7, basically I can undo my log here because they have the same basis, which means then I have x equals 2y. Very good. Or 1/2 x, however you want to write it. And that's the inverse. Okay? That'll be your inverse. Okay? What? It's fine. Don't do it away.
And it was because I couldn't see.
Try it out.
I feel like we always do the really easy ones in class and then the homework.
Well, you know, I'm trying to save a couple of the harder ones, because then we get to, you guys are going to hate me when I solve equations. I'm sorry, I already know this right now. Because you're going to have to factor with logarithms. You're going to love it.
I like that.
All right, cool, then you'll have a good time. You might even have to use quadratic formula with me.
Oh.
do that?
I hate that.
That's easy.
No.
It's easy.
I know, right? So what's the first thing you're going to do? Very good. So what are you going to do?
X equals log to the half, log half base y.
X equals log to the 1/2 base of y. Now in this case, I have to create some way to get rid of the base 1/2. So I have to think about one of my properties. Well, I have a log base, but I don't have anything with the y value to help undo it, which means I have to exponentiate. I'm going to create a base in front of the logarithm on both sides of the equal sign, which means I'm going to put this to the 1/2. Well, let me write this down here a little bit. 1/2 log base 1/2 of y. What I'm doing there is I've taken that logarithm and I've created it to become an exponent. I exponentiated it. I really hope that's a word because I want to say it. Now, if I did that on this side, I have to do the same over here, which means 1/2 to the x is on the other side. Now, do those two bases undo one another? Yeah, so what falls? Well, the y. These basically have, these kind of, that part cancels each other out and becomes pairs out with 1. And The Y fell out of the tree. The log.
Oh.
What I did.
The look on his face after he tells the joke. That's the funniest part.
I humor myself.
Because, like, the dumb joke, you'll either be like, you'll either laugh or
I can't make jokes about logarithms to my kids.
Alright.
They don't know it yet.
What jokes do you tell your kids?
Dad jokes, yes. Dad jokes.
Oh my god. They're
Okay.
the worst.
So now, now you should be able to do 48 through 64.
My foot is not that small.
Do those, please. Monday,
Every
every even and every odd, please.
That's not
So-
bad.
It's all about inverses, okay?
Wait, what page? What
It's the same stuff. It's just the same page we're on last time. I forgot what it was, 499 or something like that.
Yeah, it was for
Wait, are we adding to?
Yeah, just that's what you have. Because then on Monday, what we'll do is we'll deal with graphing on Monday. We'll graph logarithms, natural logarithms,
Yeah, make sure.
and then on Tuesday we'll start solving equations. Solving equations will probably take a couple of days. Yeah, because solving equations is fun, right? Oh no, properties. Yeah, we gotta do properties logarithms first. Or actually, you know what? Yeah, we have to do that before we do equations. Okay. So then what we'll do is we'll do graph. Monday we'll do graphing. Tuesday and Wednesday, it's gonna be at least 2 days for this for properties. Thursday we'll start with equations, and then when we come back on that Monday, oh no, we're off on Monday. We'll come back on that Tuesday. We'll probably still do equations. Wednesday will probably be a Thursday test, is my guess. It's a little bit later than I thought, but whatever. Not the end of the world. Just so you guys know, that's my best guess to put things through. Okay? Because is it next week? Next week we have a half day. We have a no school on Friday. We have Institute Day. The following week it's the Monday we're off for President's Day, but then it's we don't have anything else going on that week, right? I hope.
I hope we don't.
It's February. It's pretty common usually. All right?
Oh, that's so good.
They're logs.
You and these logs, you just need to get out of this unit so you can make a better joke.
Oh, next unit's trig. Oh man, trig's gonna be awesome. Love trigonometry.
Because of the jokes you can tell, or because
No, just because it's fun. It's actually.